Dear friends, in this video lesson, we will go through multiple linear regression with an example. How multiple linear regression, in short form called MLR, works in practice. Let us see. We will proceed with the lesson now. There is a data set which is dealing with revenue management in a hotel. Revenue in $1,000 is the dependent variable, and we have two predictor variables, percent individual occupancy and percent group occupancy. Revenue measured in $1,000, and the other two columns, namely the two predictor variables, they are expressed in percentage. There are 12 data points. You can see them. Now, we will understand the basic concepts with the example output from the Microsoft Excel. What is multiple linear regression? Multiple linear regression is an extension of the simple linear regression when the number of predictor variables on the right-hand side is more than 1. When it is exactly 1, it is simple linear regression. When it is more than 1, it could be 2, 3, 4, 5, any numbers. The predictor variables, when they are more than 1, it's called multiple linear regression. And with reference to the example we have, the original model which we postulate as the population regression equation is y equal to beta naught plus beta 1 x1 plus beta 2 x2, where y is the revenue measured in $1,000, beta naught is the intercept, and beta 1 is the slope corresponding to the predictor variable x1, which is percentage individual occupancy, and beta 2 is the slope corresponding to the predictor variable x2, which is percentage group occupancy. Now, the sample regression equation or the estimated regression model is given by y hat equal to b naught plus b1 x1 plus b2 x2, where y hat is the estimated dependent variable revenue, x1 is the predictor variable percentage individual occupancy, x2 is the predictor variable percentage group occupancy. B naught, B1, and B2 represent the intercept and slopes of the predictor variables respectively of the regression equation stated above. Now let's look at the individual important aspects or the so-called components after running the model in Microsoft Excel, and we get the output, and then we discuss the important components. So let's look at them one by one. First, the estimated regression model, y hat equal to minus 110.01984 plus 9.64993 x1 plus 8.17081 x2. The equation implies that for every 1% increase in individual occupancy, x1, the revenue will increase by $9,649.93, provided x2 is held at the same level. In other words, when we talk about the increase in x1, x2 is held constant. And when we talk about the increase in x2, x1 is held constant because both of them can otherwise vary in practice. So when we are interpreting, we have to be careful. The slope represents the incremental value increase in the revenue generated when the other variable is kept at the same level. In other words, keep X2 at the same level, keep this at the same level, and for every 1% increase in X1, the revenue is expected to go up by $9,649.93. Likewise, keep X1 at the same level, then we interpret the slope of X2 as for every 1% increase in X2, the revenue is expected to go up by $8,170.81. This is the interpretation. This tells a story for the hotel as far as the revenue management is concerned as to how effective X1 and X2 are when they are increased. This is very important. Now let's proceed to the next step. The backtracking ability of the model, we get a visual. We have got this from Microsoft Excel and made some adjustments so that the graph looks nice. And it plots the predicted revenue and actual revenue. The blue color represents the predicted value. The red color represents the actual value. And you can see the prediction more or less reflects the pattern of the actual behavior of the data points. Of course, there are some gaps. It's not perfect, but it's a very good indication that the model which we have built or estimated using the sample regression is pretty good in reflecting the pattern of the population regression. Then we get the regression statistics. Multiple R 0.963, R squared 0.9274, adjusted R squared 0.9113. The multiple R 0.963 represents the multiple correlation coefficient that exists between the revenue and the two predictor variables, namely percentage individual occupancy and percentage group occupancy. And we get here a very high positive correlation reflected by a very high value of R, which is 0.9630. Positive correlation, which is very strong. And therefore, it looks that the two predictor variables are able to capture the vagaries in the revenue of the hotel. It's a very strong correlation. Positively related, we can say. Then R squared. We look at R squared, which is 0.9274. The interpretation is 92.74% of the variations in revenue is explained or captured by the two predictor variables, percentage individual occupancy and percentage group occupancy. So the model fitted is pretty good, is fairly accurate. And this is an important input, R squared. Then we get here adjusted R squared, 0.9113. The adjusted R squared is a corrected R squared, so to say. Whenever we have more predictor variables added, there is a tendency for R squared to increase to make a correction and reflect the realistic R squared. We work out the adjusted R squared that is corrected for the degrees of freedom. And in this case, the adjusted R squared is 0.9113. And the interpretation is same, but it's very, very important for the practitioners to look at the adjusted R squared. So we can interpret 91.13% of the changes in the revenue is explained by the two predictor variables, X1 and X2, namely percentage individual occupancy and percentage group occupancy. Then the next one, the ANOVA table. In the ANOVA table, the most important thing we should look for is the computed F value, which is given by the computer output, 57.49. And the P value corresponding to the computed F value, the omnibus F, 57.49, is almost zero, because the computer has given 7.48 E exponentials minus 0.6, meaning 7.48 divided by 10 to the power 6. It's almost zero. If you go for 4 decimal places or so, 0.0000. Okay. The conclusion, therefore, is the null hypothesis that there is no linear relationship between Y and X1, X2 in the population is rejected. We conclude there is a strong linear relationship. In other words, all betas are zero is rejected. There is at least one beta which is non-zero. And because of the very high significant value, we conclude the model on an overall basis looks robust. Then we look at the regression coefficients. In other words, beta naught and beta 1 in the population, beta 2, and the regression coefficients are percentage individual occupancy beta 1 and percentage group occupancy beta 2. They are estimated by B naught and B1, which is 9.6500, 8.1708 for the two values B1 and B2. And what does it say? Compute a T-stat and the corresponding p-value of the percentage individual occupancy and the percentage group occupancy reflects 0.0016, 0.000, meaning both are less than 5% if we take alpha. They are very highly significant, and therefore we can conclude the null hypothesis in the population beta 1 is equal to 0 is rejected, beta 2 is equal to 0 is rejected. The regression coefficients are very, very highly significant, and therefore we can definitely now say all factors considered, percentage individual occupancy, percentage group occupancy, these two predictor variables are extremely important in the revenue prediction of the hotel. Thank you very much. We have concluded in a way the salient features of multiple linear regression using a powerful example. I hope you have enjoyed. We will see you soon in another video. Thanks a lot.